Smart materials. Smart materials are relatively new materials that can perform multiple tasks, also known as intelligent materials. They can change their material properties in response to changes in their environment. For example, have you ever seen a pair of glasses become darker when the person wearing them steps out into the sunlight? This is a smart material. The glasses have something called photochromic lens that changes their properties, so they darken, when the environment changes, when it gets brighter. So photo equals light, chromic equals color. Therefore, when the light changes, the color changes. There are many types of smart materials that are currently being used for many purposes. An example of a smart material that is currently being used is thermochromic pigments. So down here we have thermochromic pigments. Where can it be used? Any product that could be printed using thermochromic inks, including thermometers, security tags, or novelty clothing. What does it do? So thermochromic pigments can be applied to inks, paints, plastics, etc. They change color, chromic, when the temperature, thermo, in the environment changes. Properties changes color when there is a temperature change in the environment. Here are further examples of materials, their properties and where they can be used. So shape memory alloys, SMAs. Shape memory alloys, SMAs, are metals that can change their shape if there are changes in temperature in their immediate environment. Nitinol is a good example of an SMA. Stents are medical products that are used to hold open arteries and are made from nitinol, which is an alloy of nickel and titanium. The nitinol stents are cooled until small, then placed in the arteries where they expand with the increased body temperature. D30. D30 is a foam-like rubbery substance that reacts against incoming force. It can be molded into many shapes that fit the human form and is also very flexible. However, when struck, it firms up, which makes it more rigid and means that it has fantastic impact protection. Due to its ability to flex and then become rigid, impact protection, it is used for many products used by humans, such as sportswear, helmet pads, skater beanies, and military protective wear. Today, it is used for phone protection cases. Bought-in components. When creating solutions to engineering problems, many engineers would be required to specify what materials they would use to fabricate or produce products, as well as what processes would be needed to shape the materials. However, the engineers would not necessarily be asked to design and produce every little component that went into making that product. It is normal practice for engineers to use bought-in components. So what is bought-in component? A bought-in component would be a component needed to complete the product or solution. However, it would be purchased from a different company by the original engineer company, rather than being produced by themselves. A good example of this would be nuts and bolts. Let's say an engineer was asked to develop a seating solution for a football stadium. They could specify mild steel painted for the structure, as it is low cost and easy to fabricate, shape and join. Polypropylene polymer chains due to its durability and corrosion resistance, and then a series of bought-in components such as nuts and bolts to join the two parts together. Many bought-in components are also standardized. All come in standardized sizes and shapes, such as nuts, bolts, knockdown fittings, and other connectors. For companies, some of the advantages of purchasing bought-in components are that they do not have to manufacture everything themselves in order to complete a project. Therefore, they save money by not having to purchase extra machinery, train staff, and create extra space for this machinery/staff. In addition to this, the bought-in components tend to be manufactured by specialists, so the quality and consistency of the bought-in components are usually very good.